Okay, so do you see my Canvas screen now?
Yes.
Okay,
Yes, sir.
so go ahead and open this PowerPoint deck if you want to follow along on your computer. So I'll download it here. Yeah, I'm still admitting people. Let me see if somebody wants to get in. Okay, everybody's in. Okay, so in this lesson, we will talk about database design. We'll talk about actual objects or components that comprise a typical database, including the databases implemented using Microsoft Access database management system. And we'll also talk about some theory behind it, like why those components exist, how they're all linked together, and so forth. So the specific learning outcomes for today's lecture as follows. You should be able to explain what databases are. Also, you should be able to describe the main database objects, name them, describe their purpose. Also, we will talk about the importance of a good data model, what a good data model does to a database, how it makes a database better, more usable, more scalable, more efficient. And then we will also talk about the main elements of a data model, the kind of data model that is underlying all modern databases. So we'll talk about the main elements. For now, the outcome is to recognize, in other words, I'll mention those elements. We'll zoom in on those elements in depth starting next week. We'll talk about all of those elements in detail. So today's lecture is more of an introduction to the main elements of database modeling. So those are the learning outcomes. Okay. We have been for the last couple of weeks, we have been talking about business intelligence systems. We were talking about all the important elements of a business intelligence system architecture. So we covered all of those elements from a conceptual standpoint. So this is something that you saw in one of the slides previously, and that seems to be the logo for this course. I'll use it for my slide, follow my slide templates. Now, there are all kinds of tools and technologies that are used as a part of business intelligence systems. However, I would say that databases are the most fundamental component of any business intelligence system. You cannot really implement a business intelligence system unless you have the capacity to store, to clean, to manipulate, to manage, to update, to delete, and to retrieve data. And this is what databases are all about. As you can tell from the name, it's all about managing data, right? The first word in this term. So it's all about working with data. So what is a database? I'm getting this definition straight from your textbook. A lot of the material here in this presentation is related to tutorial A in your textbook, although we're going to go into significantly more details in relation to database modeling than tutorial A does, okay? So this definition comes from your book, from your textbook for this course. So a database is a group of related objects that support data storage, access management, and analysis. So even a relatively simple database management system such as Microsoft Access has all kinds of capabilities for all needed capabilities for data storage, access management, and analysis that a small to medium-sized business can possibly need. So that's our definition. Now, there are different types of databases out there, and I would say that nowadays there are two main types of databases. Although you can subdivide those types, those two main types, into subcategories as well, like online databases, open source databases, business databases, and things like that. But I would say the two most important categories nowadays are relational databases and non-relational or NoSQL databases, okay? Examples of relational databases include Microsoft Access. That's what we're using in this course. I already mentioned several times that Microsoft Access is more like, is a suitable solution for small to medium enterprises. If you're talking about an enterprise-grade solution, which means an organization with, I guess an enterprise is usually defined as 500 plus employees, then you will need to have, then most likely you'll end up using Microsoft SQL Server database management system. If you're dealing with websites, with web databases, then a very popular platform is MySQL database. It's an open source database management system designed specifically to be online to support websites. All kinds of popular websites are using MySQL. Usually it's a modified version of MySQL because they get the source code and they modify it for their needs. From what I remember and from what I've heard, websites like Wikipedia, they use MySQL database to support their data storage. Now, why are those databases called relational? Because of the fundamental aspect of their design. Relational databases are usually designed by specifying tables where you store data and also relationships among those tables. So a relational database can be viewed at the architectural level as a collection of tables linked together through certain relationships. And we're going to talk about how those relationships are implemented in detail for the last couple of weeks, but that's what it is. You have a bunch of tables. Each table is devoted to a concept, like, for example, a student, a customer, and all those tables are linked together in a meaningful way. The reason I'm saying meaningful way, because everything in this world is linked to everything, right? I mean, I'm pretty sure if we go like, I don't know, 5,000 years back, then some of us is, here in this class, actually relatives. Maybe we have some common ancestors 5,000 years back, going 5,000 years back, right? But it doesn't mean that we're relatives, right? I mean, we're not really related. So that's what I'm saying, meaningful relationships. The relationships that are important are implemented in a relational database, not all relationships. And then you have the so-called non-relational or NoSQL databases. Examples of those databases include Apache Cassandra and MongoDB, Mongo database. I have certain limited experience with Cassandra. I haven't used the Mongo database, at all. Okay, but this is the essence of those databases. You see, with the advancements in the so-called big data movement, nowadays there's so much data being generated, particularly online on the web, and that data is messy. I mean, it takes all kinds of forms. For example, if you're talking about online data, we're talking about blog posts, we're talking about web pages, we're talking about, videos, YouTube streams. So all this data is huge, and it's also not as structured as relational databases needed to be, okay? So non-relational, non-SQL databases, they allow you to store data using an architecture that is not as organized as the one that is used by relational databases. So you can quickly add huge chunks of data to your collection and not worry about specifying relationships and tables and attributes and their data types, okay? So NoSQL or non-relational databases, they are more aligned with that big data movement where you have those humongous data sets of semi-structured data that cannot be easily organized using the relational model, okay? But I would say still that the relational model is the predominant model, especially if you're talking about small to medium business. If you're talking about a large enterprise, then NoSQL solutions would probably be more common to deal with petabytes, if not zettabytes of data that is being stored in data warehouses by companies like Amazon and Walmart, okay? So we are dealing, I would like to say it one more time, in this class, we are dealing with relational databases. So most of the things that we cover, most of the things that we say are related to the relational architecture, relational model for database management systems. Okay, so now we know what the database is. It's a collection of objects for supporting data storage, retrieval, and management. So what are the specific database objects in a typical database? Well, in a typical Microsoft Access database, and this list is not exhaustive, I'll tell you that, in some databases, there are additional elements that are very pronounced, like triggers, all those, I guess you can call triggers as macros that cascade certain changes throughout the database. But in a typical Microsoft database, the typical objects include, number one, tables. I think, I'll show you some examples of tables, but I think the name itself is kind of self-explanatory, especially if you're an IT major. So think of it as like some kind of Excel sheet table, right? For example, table containing information about students, okay? So each table is devoted to one class or concept, like student, customer, teacher, instructor, client, and things like that. Tables store data in the form of rows also called records, and columns called attributes. Okay, so a typical table looks like this. So here we have a table devoted to customers, right? So we have rows devoted to specific customers. In ARD modeling, they call those rows as instances of a class. So for example, customer is a broad class of people, right? And then we have a specific customer here named, I don't know, Kathleen Davis, right? And Kathleen Davis is a specific instance of that class called customers, right? So rows represent specific people or specific instances of that class of people called customers. While columns or attributes or fields, that's another popular name in database design, represent what? How would you explain it? So if rows represent customers, then columns represent what? How would you explain it using common language? Okay, let's ask Amanda. Are you there?
Can you repeat the question?
Well, I'm saying, here's a table devoted to customers, and I'm saying each row represents a specific customer, right? So this row represents Kathleen. Okay. Now, what do columns represent in relation to Kathleen?
Like their individual, like the information specified, like their city, their address.
Okay, and collectively, what we can call them what? Like properties of those customers, right? Some characteristics, like for example, Kathleen, she has the following characteristics: address, city, state, zip code, email address, and so forth, right? So this is what we mean by a table. Then we also have forms. Forms provide an interface for users to access and modify data in tables. Again, if you're an IT major, if you took a course related to programming using a visual, using an integrated development environment IDE, you saw those forms, right? For example, in Visual Basic, you can create those forms. And forms look like this. Let me show you quickly. So this is a form where you have labels, where you have data points. You can use this form to access and modify data. So it looks something like this. That's a typical form in Microsoft Windows. Forms provide interface, right? So it's like a window for users to access and modify data in tables. Then you also have reports. Reports are like summaries that are generated based on data contained in tables, okay? So you can create reports about most valuable customers in terms of the revenues that they bring in. Okay, so I'll jump forward a little bit. A report would look something like this. It's a document, right? So here we have a summary, and we'll go back to this example again. Here we have a summary of customers and their dogs, and also when those dogs had an appointment with your business. Also, you have queries. You can think of queries as questions that you ask your database. For example, how many customers live on Elm Street? Let's say that's your street. The reason you want to know, because I guess those are the best customers. You don't have to commute to pick up their dogs, okay? So this is an example of a query. You ask database a question, and that question is answered using the data that you need, okay? So once again, those are the typical objects included in a database, such as Microsoft Access. Now, I already showed you some examples from a database that I'm using as an example for this lecture, so we can visualize some of those elements, attach their graphical representation to those definitions. Let's do this if you don't mind. The first thing that you can do, you can open that database on your computer if you want to look at examples on your own screen. So here's the database. Where is it? Just one second. Oh, sorry. Okay, so this is the database. It's called Dog Hikes. So go ahead and open the database so you can have it in front of you. You can refer to our examples directly from the database. So if you have Microsoft Access installed on your computer, you can do that. Alternatively, you can use Microsoft Office 365 to open this file. Personally, I haven't used 365, but that shouldn't be an issue. I mean, 365 is compatible with Microsoft Access 2019, so I don't see a reason why you should not be able to open it. So here's the database open on my computer right here. So were you all able to open that file from Canvas?
Yeah, I was.
Okay, which Access version did you use?
I think 2019 is installed in mine.
Okay. Did anyone use 365?
I'm working on it.
Okay. So I'll give you a couple of minutes to open it. And if you're done, I would like you to read this case. Again, it comes from your textbook. So probably you've noticed that we are now using the textbook, which means that you need to get a copy. We will be using this textbook quite heavily. So it's not going to be like one of those wasted money cases where you buy a textbook and you never end up using it. Okay, was anybody able to open it using 365?
I think mine opened at 365.
Okay, it worked?
Yeah.
Okay, good. Okay, so once you open that file, I would like to ask you to read this preliminary case. Oops, I think we didn't let somebody in. Oh.
My case is just loading too.
Hey, Zach and Jiwa, I'm sorry, I didn't see that you're waiting to be admitted to this room. I actually checked, right after we started, and I usually get notifications if somebody's waiting, but I didn't see any notifications for you.
You're fine.
I guess that's the punishment. If you're not here at 2, I may forget to admit you to the room. I had once an instructor like that. He physically closes the door, like when the lecture starts, and he doesn't let you in. So people, do you have instructors?
Where's the file at?
Okay, so you should be able to see it here. I'm sharing my Canvas screen, right? So the database file is right here. It's called doc hikes. That's the database that we're using as an example. And once you open that file, you can either open it using Microsoft Access installed on your computer. I think 2019 or 2016 will work. Both of them will work. If you don't have anything installed, then please use Microsoft Office 365. I showed you last time when you were in the lab how to access Microsoft Office 365. I think the URL is actually office.com, right? So this is the 365 link. Okay.
So I used Office 365 to access
Okay, good.
access in class, but now it's not even showing access as an option on.
Yeah,
Office 365.
I'm a bit lost myself because I thought it's here somewhere.
Yeah, it's this one.
Yeah, I have PowerPoint. Okay, guys, well, if you don't have anything installed, then you will just have to look at my screen for now. I need to ask our IT director, like what's happening with Microsoft Access. For some reason, I was operating under the assumption that Microsoft Access is a part of everybody's Office installation. So I think somebody already told me that, that they have Microsoft Access, right, in their Office 365. Is this correct?
Yeah, I'm pretty sure mine opened in 365.
Okay, well, I don't have it here. So I'll ask our IT director, I'll put a note. How come some people have 365 in their Microsoft Access in their 365 while others don't? Well, for now, it's not essential. It's more as an example. Later on, we'll meet in the lab, so that shouldn't be an issue because all the labs have Microsoft Access installed.
Were you able to open it?
Okay. Okay, well, regardless of whether you have opened the database or not, I would like you to read case 1 right here. So it's a PDF file. I copied it from the textbook, and I will do it for the first couple of assignments. I will give you a copy of the case. So in case you don't have a textbook, you can have it in front of you. But then out of fear of FBI, I don't want to be prosecuted for copyright infringement. I will stop at 10%. So in other words, in accordance to the fair use policy, I can copy up to 10% of copyrighted material, but not beyond that. So I'll make copies of the first couple of cases for this example, and then for your next assignment. But after that, you need to have your own textbook, your own copy of the textbook to access those cases. So please read this case so you understand what this database is about, because I'll use this database to show examples of tables, forms, reports, and queries. If you were not able to open the database, that's fine. I have screenshots, so you'll see it from the screenshot. So I'll give you 5 to 10 minutes to read this case. Hey, Zach, were you the person who didn't have Microsoft Access in 365 last time? I remember you were upset about it. Was it you?
I was able to figure it out. I actually, I have,
How did you make it appear there?
well, I wasn't able to get the web version, but I already have Microsoft Access on my computer itself. So
Okay. But you were not able to get it on Microsoft
Not the web.
Office web. Okay.
not the web version.
Okay.
One time, if you have a Murray State email and you're a student, you can actually get a free Office, or at least I was able to a couple of years ago.
Oh yeah, that's a good point. There is an initiative at Microsoft. They keep changing the name. I think at some point it was called Spark or something like Microsoft Spark. Now it's called Microsoft Imagine or something like that. I'll upload those instructions as well. Because indeed, as a Murray State University student, you can install all kinds of Microsoft Office applications for free. And I think the duration is like 6 months, right? So that will do for the purposes of this class. So I need to put a note. So I'll post a link to technology resources as well. I do have a short manual on how you as a student can register for that Microsoft initiative. I think it's called, what's the name? Is it Imagine or Spark? I think it's Imagine, right?
I'm not sure. I just remember several years ago doing that when I was taking some classes.
Yeah, that's a good point. I'll find that manual that I have that shows you how to access those installer files from Microsoft, and I'll post it here. So that will be another option if you don't know how to get a hold of it. Okay, right. So I'm done reading the case, and I'm hoping that most of you have finished reading the case as well. So you understand the nature of the business for which the database was created. Okay, so basically, your friend who lives in Chicago decided to start a dog walking business because apparently residents of Chicago, they keep their dogs in confined spaces in small apartments. And dogs, because of that, they do not get enough exercise. If you're a dog owner, you know the problem with the dog not getting enough exercise, especially if it's an energetic breed like Labrador. I mean, they will go crazy in your house. They will chew everything. And overall, they will be like in a crazy mood all day long if they're not walked properly, if they're not exercised properly. So your friend offers people to take their dogs for a hike in the country. The fee is $85. So she I think it's she. Well, I don't remember. Well, anyways, Shin Mu. Yeah, she commissioned you to create a database, and the database is largely, it's not about accounting, it's not about bookkeeping. It's largely about just keeping track of customers, their dogs, and their hikes. So each hike is like an appointment for which Shinmu charges $85. Okay, and then you also commission to create certain queries, meaning certain pre-programmed questions or manipulations to the database that she would like to use as a part of her business. For example, deleting a hike. If somebody cancels an appointment or the weather is bad and a dog hiking appointment needs to be canceled, then you'll go ahead and delete it using that delete query. Okay. Then there's a form for browsing customer records in their dogs, and there's a summary report that kind of lists all customers, their dogs, and their hikes or their appointments. Okay, so that's the essence of the database. So it's more about keeping track of customers and their dogs and their hikes, right? It's not about bookkeeping. So it's not like a database that will automate your entire business, but it's something that is automating that customer-facing set of processes. Okay, so that's the database that I will use for my examples in this lecture. Okay, so we stopped here. I'm kind of repeating for people who join us a bit late. So we discussed tables, forms, reports, and queries. I just gave a brief summary of what those things are. So now we're going to discuss tables, forms, and reports in a bit more detail. So here you have a collection of database objects. Again, if you open the database, you will see that the objects are on the left side. So we have 3 tables, we have 5 queries, we have 1 form and 1 report, and all of those things are database objects. So we have, once again, 4 objects: tables, queries, forms, and reports. So let's talk about tables in a bit more detail. So the first thing I would like to say is that sometimes people are tempted to pack everything that is needed for a business into one single table. Later on, you will see that it's a bad habit in relation to database design, because if you do something like that, if you just pack your information into one single table, then it becomes very complicated to update the table and overall wrap your brain around the table in case something needs to be modified if you want to add additional data points. So a good practice in a database design is to create one table per concept, per class of things about which you need to store data. For example, if you need to store information about customers, then create a table for customers. Now you may say, well, why don't we create a table that stores information about customers and their dogs? Well, trust me, that's not a good way to put together a database, because you will have some problems down the road when it comes to updating, deleting information about dogs while keeping information about customers intact. So if you want to store information about dogs, then create another table devoted to dogs. Okay. If you need to store information about hikes, that's a different concept, and create a separate table for storing information about hikes. Don't just lump everything together into one single table, because later on it will lead to all kinds of problems in relation to database architecture. So once again, here specifically, we have a table that stores information about customers. Okay, so records or rows represent specific instances of that class of people called customers. So in our case, each row, each record represents a specific customer. For example, Kathleen Davis, that's one of the customers of this dog hiking business. Okay, so rows represent specific customers or specific instances of that class or entity. So class, entity, those are synonyms. And then we already said that attributes represent properties of those specific instances, right? So for example, each customer has a property called zip code. So that property reveals where that particular customer lives. Okay, then we also have email address and so forth. So columns represent attributes, and attributes are also called fields. In some database management system, a popular term for those columns or attributes is fields. I think most of the time I will say attributes. I will use the term attributes to to refer to specific properties that characterize instances of a specific entity. Okay, now let me show you how it will look in the database. What I'm trying to say here is that each attribute or each field, I think in Microsoft Access it's called, yeah, it's called field. So maybe we should use the term field. Each field can be of certain data type. So let me show you how to switch between those views. So here, when I double click on customers, I see the data, right? And then in the view, you can use this view option to switch from the datasheet view that shows you the data to the design view. Okay, so here you're not dealing with table data, you're dealing with table design. So here we have fields or attributes for customer listed. Okay, so we have customer ID, first name, last name, street address, and so forth. Okay, one thing that I don't like about this book, I don't like it when people leave spaces in field names. Okay, if they leave spaces, then things become a bit complicated. When you refer to those field names as variables, for example, as a part of a query, you need to put square brackets around it. Okay. Personally, I don't use any spaces. Like if I create, a field name that has several words, I would spell them out as one word. I will just use capitalization to separate those words. Okay. In Microsoft Access, capitalization doesn't matter. That's what I remember. So it won't impact it in a negative way if you just use capitalization. I mean, capitalization will allow you to separate those words visually, but it will not create any kind of hassle when it comes to referring to those fields by name, right? But here we have spaces. If you have spaces, just don't forget, you need to put square brackets when you refer to that field name, let's say as a part of a query, right? So a lot of mistakes are because of that data entry error, something related to that space, and people don't understand why their query is not working well. Just keep that in mind. If it's a query, if your field name has a space, then you need to use square brackets around it. Okay, so so here we have the design view for the table called customers. So here we have all the fields or attributes spelled out, and then we have data types attached to each attribute. So you can have the following data types in Microsoft Access. Okay. Short text, long text, number, large number, datetime, currency, auto number, yes, no, which is a Boolean data type. It can be an object, for example, like a Microsoft Word document, hyperlink, attachment, a calculated field, and then so forth. Okay, so this is how you view it in the design view, where you can change the names of attributes and also modify their data type. By the way, if it's a short text, then the field size is usually up to, it's up to 255. So here, for some reason, for the first name, we have a limit of 50 characters. Okay, so that should work for most people. Okay, so this is customers table. Another thing I would like to mention about the customers table is that one attribute has to be designated as the primary key. Okay, you see that key right here? So that means it's a primary key, and you see this button is pressed. Okay, so I'll not change it because I may forget to designate it as a primary key again. So in every table, you need to designate an attribute as a primary key. By primary key, we mean the primary identifier. We mean an attribute that assumes unique value for every instance of that entity. Okay, so in other words, you cannot select an attribute that can be repeated, right? That can be repeated for different instances. It can be the same for different instances. For example, do you think you can use designate customer first name as the primary key? Is it a good idea or not? What would you say?
No, because they could have the same name.
Yeah, that's not a good identifier, right? People may have the same name, like several customers can be named, for example, John, right? So that's not a good idea. But customer ID is that artificial identifier that we created to make sure it's unique. The number is unique for every customer, and it uniquely identifies every customer. Okay, so let's look at some other tables. We have dogs. So once again, we have dog ID, which is the primary key. We have dog name, breed, and then each dog is linked to a customer. So that already tells you that this is how those relationships are implemented. So dogs are obviously linked to customers because customers own dogs, right? And to show that link, we insert customer ID, which is the primary key here, right? So customer ID is inserted in the dog table. you don't have to like memorize those things now, like to memorize those definitions, but we'll discuss those concepts in a bit more detail. But for now, I'd like to say that if you have a primary key from one table, insert it as a part of another table to show how those tables are related. In our case, we're showing how dogs are related to owners. That inserted key from another entity is called foreign key. Okay, not a primary key, it's a foreign key. The primary key here is the dog ID attribute. Okay, customer ID is the foreign key. Foreign means like not from here. Foreigner means not from here, right? So foreign key means a key that comes, a primary key that came from another entity. Okay, so that's a foreign key or FK. And here we have information about hikes. So here we have dates and dog ID. So for example, this dog with ID 101, and that's Max, who is a Labrador, went for a hike on the following date. Okay, now let me show you something about that hikes table. I'll go to the design view once again. As you can see, we have two attributes designated as primary keys. In fact, you can say that this is one primary key. Okay, in other words, the unique identifier for every record in this table is comprised of two parts: appointment date and dog ID. Okay, to uniquely identify each dog appointment. Okay, now this, in a way, you can think of it as one primary key consisting of two parts. And when you have a primary key consisting of two or more attributes, let's say 2, 3, 4 attributes, it's called compound primary key. Okay, so this primary key for this table or entity called hikes is compound. Okay, what does compound mean, by the way? Like how would you explain the dictionary meaning of that word? So what is a compound? Okay, let me ask somebody. Okay, Cameron, what is a compound? How do you understand the meaning of this word?
Sorry, which word?
Compound. I'm typing it here. I think that's how it's spelled, right? So you don't know what compound means?
It's like two things put together.
Okay, I like that. I mean, yeah, compound can have many meanings. Like I think in architecture, by compound they mean like a collection of buildings. Like in the Middle East they use the term all the time. By compound they mean like a small neighborhood that has apartments, houses, cafes, shops. So compound means a collection of buildings, right? I think in chemistry when they say compound they mean a chemical element that is comprised of other elements when you mix several elements together, right? So I think compound means like a combination of things, something complex, right? So a compound key is a combination of other attributes. Okay, so that's what I wanted to show you here. The primary key here is a compound primary key. It consists of several attributes. Yeah, so this is how it's spelled, compound primary key. I think I was right. Now, you saw there are, generally speaking, those are general categories. You saw that there are some nuances in Microsoft Access, like you have short text, you have long text, but generally speaking, attributes can be of the following data types. And you can look up those data types here when you go to the design view for each table. So this is where you can specify the data type. So it can be a text for storing textual information. It can be in integer for storing whole numbers. So if you want to store somebody's, I don't know, what would be something that is usually whole, like age in years, although it's not a good idea to store age in years because it has to be updated every year. It's better to store date of birth, but that would be an example of an integer value. Like you don't store people's age like 20.25 years old, right? It's just 20 years old. Double for numbers that have a decimal value. So that's a bit of a more memory consuming data type. Currency, self-explanatory. If you're storing something in relation to dollars or some other currency, use this data type. Then you use yes, no data type for variables that assume only two values, like on, off, true, false. In most programming languages, that yes or no data type is called what? What's another name for this type of variable?
A Boolean?
Yeah, Boolean, right? Or logical, usually Boolean, that's the most common word. And then you also have date time data type for attributes. Now you may say that, well, date is a number. Well, it's not really a number, right? I mean, you cannot really multiply or subtract dates. You can do subtraction, but it's not the arithmetic subtraction, right? To calculate days in between, you need to use a different computational logic, right? So that's why, to make sure that nobody subtracts or multiplies dates, you use a different data type for variable storing dates. Okay, so those are the common data types of attributes. Now I have a question for you. I wonder, like, what would be your explanation? You see, we have our table for customers. Okay, and here yeah, for example, telephone number is a text. Okay, how come it's not an integer or a number? What would you say? Like, why did we use short text?
You might use dashes or brackets.
Yeah, indeed. Like if you go to the data view, close it. Yeah, you see that we're using dashes, right? So this is more of an alphanumeric string. It's not just a numeric string. You know, I would use short text even for zip codes, because in some countries, zip codes, they actually have letters in them, like in UK or Australia, right? But if we're running this application in the United States alone, where zip codes have only numbers, then it's okay to store zip code as a number, right? It's not a double, right? It's not a number that contains a decimal point. Okay. Okay, so this is a table. So we talked about tables. We talked about rows, what rows represent, what columns represent. We talked about data types for attributes or fields. So next we're going to talk about forms. So a typical form looks something like this. Forms, they're like an interface. They provide an interface that users, and by users we mean somebody who is not a technical worker, somebody who is not a database administrator, somebody who is just using your database for business purposes. So forms provide that interface that users can use for accessing and updating data. So why do we need to use forms instead of just going? You see, instead of using a form, we can go directly to the table and update it, update information about customers. Well, first of all, most people find it's more convenient than using tables directly, because if you give somebody a bunch of tables, they may get lost. So it's much better to create an interface, a visual interface, and say, look, if you want to work with customers and their dogs, use this form, right? Don't go to tables. That will be a bit inconvenient and complicated. And it's also a way to restrict users' data access. You give people a form so that they access certain data types and don't access other data types, right? So that's a way of segregating users based on their data needs, so that things don't overwhelm them, and also to make sure that they don't mess up the data that they have no authority to access, right? For example, if you're somebody responsible for scheduling dog hikes, then maybe it's not a good idea to give you access to tables containing financial information, because that will be accessed by somebody who's an accountant, right? And it's not that you may have like malicious intentions to modify the data, but sometimes by accident, by mistake, you may modify data that you don't have authority to access, and that will create a lot of problems for people who actually are using the data and who have authority to access the data. Okay, now let me show you how this table, how this form looks in Microsoft Access. So this is the form. So when I double click on that form, you see that it's something called a form within a form, a parent form that allows you to browse through customers and their information. And then there's a child form, a link form that links customers to their dogs. So not only you see information about customers, you also see information about their dogs. So this specific customer with ID 115 has two dogs, a Labrador named Max and a Beagle named Buddy, okay? And you use this button right here to go to the next record, which means to go to the next customer. So now we have customer with ID 16 who has only one French Bulldog named Cooper. So you see, we're using those forms to browse through our customer records, okay? Now, you can also use those forms to modify data. I will do it right now. For example, this customer, let's say I made a mistake and the last name is Williamson, not Wilson. So I can change it here. Okay, so when you scroll back and forth, you see that the record has been updated. I'll change it to the original Wilson and so on. You can also use this form to add information about dogs, to update information about dogs and so forth. So that's the point of having a form, to provide an interface that users can easily use for accessing and modifying data. Okay, reports. Reports, they're like documents generated based on data. Oh, by the way, there's one point I would like to make. So you may be wondering, how does this form know that certain dogs are linked to certain customers? For example, how does the form know that customer with ID 115 owns 2 dogs? The answer is that we have a database model specified that links those 2 tables together based on a shared attribute or key. So I'll show you this right now, and then we'll discuss it a bit later. So you go to database tools and you look at the relationships among those tables. You see that dogs are linked to customers, right? So, so this line represents relationship between dogs and customers, and the relationship is clear, right? I mean, customers own dogs, or dogs belong to customers. You can explain it, both ways. Okay. Now, I told you that those relationships, those tables are linked through certain common elements. So what is the common element that kind of shows you that dogs are linked to customers? And we already touched on that when we looked at the table containing information about dogs. So what's the common element between customers and dogs? Common attribute, let's be more specific.
Customer ID.
Yeah, customer ID, right? That's how we link those tables, right? That's how we know that dogs belong to customers, because here you see that dog named Max has the following customer ID attached to it. So we're using customer ID to link those tables together, right? And what you see here are cardinalities. Those numbers represent quantification of this relationship, okay? So for example, what this means, this means infinity or many, right? In ERD modeling, it's called many. And here it's number 1, okay? So what this means, it means, look, customers and dogs are related. That's what this line represents. There is a relationship between customers and dogs. And that relationship is implemented by using customer ID, okay? Now, many means this. It means if you take customer, any customer from this table, this customer can be linked to many dogs, okay? By the way, in database design, once it's more than 1, you just say many, right? If it's 2, 3, 4, and so forth, you just say many. So this infinity symbol represents many, okay? So the cardinality here, those numbers, they quantify the relationship. So here, you're saying one customer can own many dogs. Now, if you go from dogs to customers, you're saying that one dog is owned by only one, belongs to only one customer. So that's what 1 represents. If you're going this way, right? Each dog, you see, can have only one customer, one owner, okay? Now, you may argue, well, some dogs are owned by several people, like by, let's say, by a couple, husband and wife. Well, you see, like, that may be true, but for the purposes of designing a database, you treat one dog belonging to one customer, one person. I guess it makes your day-to-day management of your business easier as well, because you know that, well, that's the person who I need to contact in relation to this dog, right? So I guess what I'm trying to say, sometimes you have to make simplifying assumptions to keep your database structure simple, right? You don't want to make it too complicated by including several owners and somehow modifying your database architecture to allow dogs to have several owners. So you're making that simplifying assumption.
Question, it might be a dumb question.
Go ahead. There are no dumb questions here.
When you've got like multiple different tables like that and they're linked, and let's say customer ID, let's say you're in the dog field and you realize your customer ID is, you put in the wrong number and you update it, will it automatically update it in any linked fields as well? Or do you have to update them in both simultaneously?
Yeah, there is an option for that. So I think by default, the changes are cascading through the entire database, right? I think you can specify not to cascade changes if you do any deletions. So you can do both. Yeah, like for example, if you specify cascading changes, if you delete a customer from your table, then if you specify that cascade changes, it will trigger deletions in all linked databases. So you can do it both ways.
Okay, so that's just like a setting you can adjust then?
Yeah, yeah.
Thank you.
I think right now by default it's not cascading. If you delete a customer, it's not gonna delete customer IDs from all the dogs. You can try doing that, by the way, on your own machine. But you can specify that when you specify those relationships, you can this is the property, you can cascade deleting records. Okay. So that's the option. You can experiment with those options and see what happens. I just double click on the relationship to open those cascading options. Okay.
Thank you.
Okay, so yeah, so sorry, I digress a little bit. So now we're talking about reports. So a report is like a summary, it's something that summarizes data in the form of a formatted output. Reports is an output in the sense that it's a document, it's a visual document that you will share with end users. You can export, you can export this report and send it by email. You can print it. So this is something that, that is used for communicating. So generating, it's something that is used to summarize data in the form of useful information. In our case, this is the useful information. The owner of this business, Shin Mu, she wants to see all customers, all dogs, and all of their hikes, so that the totality of the schedule, right? Maybe this report can be used to see how to bill customers, because if a customer named Angeline had one hike, then you will bill this person, this client, this customer for one hike. This person named Charm, I guess that's how you pronounce the first name, should be billed for 5 hikes. So 5 times $85, right? So this is the kind of information an end user can get from that report. So yeah, it's about sending somebody like a snapshot of data. Usually the data is summarized, it's aggregated. So report is not just like a raw data, it's usually a summarized data, maybe aggregated data by customer or by dog, okay? Also, I would like to mention one thing. Usually a report, you can generate reports directly from your tables, but it's considered to be a bad practice here. So this is the report that I'm close everything. So this is our report, I showed you on the slide. So this specific report is generated from this query summary report. Okay, that provides information for all customers, for all dogs, and all the appointments. You can generate that report directly from those tables, but it's considered to be a bad practice. You need to generate it from a query. It's something related to database access. It's considered to be, remember we talked about data warehouses and independent data marts, and we said that data marts are subsets of the entire data warehouse. So that's what you're doing. By creating a query, you're creating a subset of all those tables of data contained in all those tables. So each time you generate that report, you modify it, you don't have to query the entire database, right? So that's the essence of this good practice. You're not querying the entire database each time you generate a report. You're using a subset of the data generated by a query, okay? So usual reports, or it's recommended that reports are generated based on queries. And in this class, we'll generate reports as a part of your assignments, okay? Okay, so this is a report. Next, we're gonna talk about queries. So we already said that queries are like questions that you can send to a database, at least the select type. You see, queries can be of different data types, of different types. The most common type of queries is probably the select query. So the select query answers a question or provides data or information, and a select query would retrieve that data, that information from your tables, okay? So select means give me information, select information about dogs or about customers, okay? For example, this query summary, the one that was used to generate the summary report, it kind of says something like this. I want to have information about customers, specifically from the customers table, specifically first and last name of customers. I also want to see information about dogs attached to those customers, owned by those customers, and also their hikes. So as you can see, this query retrieves information from all 3 tables, not entire information, only certain attributes from customers, from dogs, only dog name, right? No dog ID, and then appointments, okay? So dates when that particular dog went on a hike, okay? So in Microsoft Access, this is the query. So when you click, this is the output, right? And as you can see, this output is used to create a report like this, because this data, everything that this report contains comes from this output. Now, when you work with queries in Microsoft Access, you can go to the design view. So you see Microsoft Access has this visual point and click interface that allows you to specify, okay, I need first name from the customers table. I need last name from the customers table. I need dog name from the dogs table. So this is like a visual interface used to create a select query. You see this button is pressed, it means it's select query, and you can run it to get an output, okay? However, sorry, I'll close the report just to make things less complicated. You can also have the so-called SQL or SQL view, where the same type of operation is implemented using SQL language. In this class, we'll learn the basics of SQL language and we'll practice certain SQL statements in relation to a database, okay? But I'm just letting you know right now that whatever you do through that visual interface can also be written as a SQL statement. Once again, SQL stands for structured query language. It's not sequenced query language. So please make sure you know what SQL stands for. It's structured query language, once again. Okay, so this is one query. By the way, we have 4 query of the select data type. For example, this query, just as the case explains, allows you to see customers that live on Oakmont Road. I don't know what it is. I think, I forgot what the case mentioned about that road. But anyways, you can use a query to select information about dog owners only if they live on Oakmont Road. So if you go to the design view, you will see that there's a filter. There's a criteria that filters customers. So you're selecting information about customers only if the street is like Oakmont. So basically, like means approximately equal, right? Because there may be like, I guess, alternative spelling of the street address. And if it's spelled a bit differently, if there's an extra space or anything like that, it will still capture the fact that this customer lives on Oakmont Road, okay? So this is another select query with a parameter, with the criteria. Now here you have a query that answers the following question: who are the owners of a particular breed? Okay, so let's say, let me look up those breeds here. So we don't have, so each breed is different. Well, yeah, so we're not going to have a bunch of customers for a particular. So let's say we're talking about Labrador, right? So this is a parameter query where you need to enter a parameter. So I'll enter Labrador here. And it will show the name of the owner who owns a Labrador named Max, okay? Then we have number of hikes. So here it's a summary where we have dogs, their breed, and number of hikes. I think the case says that for some reason, the owner of this business wants to see which dogs get the most hikes. I guess maybe it's related to profitability analysis. Which dogs and which breeds are most frequent repeat customers. So it looks like the 3 dogs that went on most hikes, which is 3, are Max, Rocky, and Tucker. Okay, so that's what the query does. It basically says, okay, show me the most walked dogs and their names and their breeds. Okay, and sort the output from highest number of hikes to lowest number of hikes. Okay, and then we have another. So we mentioned here that queries can be of different types. So I showed you examples of select queries. Queries can also do update, meaning change, modify value. Queries can also append, which means adding. They can add a record, and sometimes that record can be added based on certain manipulations, calculations with the data that is already in tables. And also queries can be of delete type, where a particular record is deleted. Okay, so let's see how it works when it comes to deleting. So it warns you that you're about to run a delete query that will modify data in your table. Okay, so this specific delete query is used to delete a hike. Okay, so for example, if a particular dog hike is canceled, then we'll go ahead and delete that hike from our records. So let me see first what kind of dates we have. So now we have the following date, 2/12/2020. So let's see whether it works. And then it says, okay, for which dog do you want to delete that hike? So let's say we are deleting for dog 101. So it says you're just warning you that you're about to delete one row. So you press yes, and this hike should be deleted. Let's see. So you see that record has been deleted. Okay. So that's an example of a delete query that allows you to delete records based on certain parameters that you select. Now, I already mentioned that, right? So you can view the SQL version of those queries that you create using the point and click database. To kind of wrap up this lecture, we talked about the following 4 objects or 4 elements of a typical database: tables, forms, reports, and queries. Now, at this point, you may be wondering, like, how all those deletions and how those queries know that you need to get information from multiple tables and only information that is related to a particular record in the table. For example, how does the database know that that certain dogs are linked to certain customers so that it can display information aggregated by customers and dogs, right? Well, the answer is a data model. I already showed you how it looks like. In Microsoft Access, you can see the data model by going to database tools and then relationships, okay? So this is where you will see the model, okay? And whenever you build a database, you need to start with that. You need to start with tables and specifying relationships among tables, okay? And we'll see how it's done later on when we build actual databases. So what makes all those elements possible, such as queries and reports, is a good data model, a solid data model that outlines the structure of the database by specifying tables and their relationships, okay? And once again, that's why it's called a relational database, because the architecture, the structure of the table is specified in terms of tables and relationships. So you see that these tables are related, right? And those relationships are specified are indicated using those lines. So once again, you need to start every database with a good data model. A good data model makes a database simple. By simple, we mean it's easy to understand what is being stored, non-redundant. We'll see examples of that later on, but sometimes you will be kind of wondering, well, where does a particular attribute belongs? Does it belong to a dog or a customer, right? So if you have a good data model, you will see that, well, this attribute describes dogs, so that's why it should go into the dog entity or dog table, okay? And also scalable. When you have a database that is simple, non-redundant, it's easy to grow it. It's easy to add additional tables. It's easy to modify those relationships. If you have a very complex, cumbersome, redundant data model, it just makes it harder for you to understand what the database is and how to modify it, okay? So once again, let me summarize everything that we have discussed so far, and I'll use this slide. So those are the most fundamental elements of a good database model or data model underlying a database. First, we have entities with attributes. I think most of the time I say entities, but hopefully you saw that by an entity, we mean a table, okay? An entity is some kind of abstract class of things about which we need to store data. For example, we need to store data about customers, so we create a table or an entity called customers. We need to store data about dogs, so we create an entity or table called dogs, right? We need to store information or data about hikes, so we create an entity or table called hikes, okay? Each entity has attributes. So for example, customer has the following attributes: customer ID, first name, last name, street address, city, and state, okay? Again, I think it's easy to think of entities as tables. So you saw that those attributes, they become columns, right? They become columns within a table that is used to store information about customers. So rows represent specific customers, columns represent attributes or fields, as they're called in Microsoft Access. We also said that this is a relational database. So those tables or entities, they're linked together using relationships, okay? Now those relationships, so here visually, they're indicated they're implemented using a line, right? At the table level, those relationships are implemented by sharing certain attributes. So the reason you know that dogs are related to customers is that the customer ID is inserted in every dog record to indicate that this dog is related to a customer, right? So at the visual level, like visually, those relationships are indicated using lines, okay? At the table level, those relationships are implemented using keys, right? Shared attributes. We already said that a primary key or PK is a unique identifier. For example, dog ID is a unique identifier. It's the primary key. That's why you see the key icon right here. So customer ID is the primary identifier, is a unique identifier or primary key for the customer table. So you see that key icon, right? So it's called primary key. So the primary key of the dogs table is dog ID. The primary key of the customers table is customer ID. Since we are taking customer ID primary key and inserting it into the dog table to indicate the link, the relationship between dogs and customers, it's called foreign key, right? Foreign key is a primary key that comes from another entity, right? So that's what we mean by a foreign key or FK. And then we also said that some primary keys that are compound. Somebody told us compound means has several parts. It's a complex key. So in our case, we have hikes, which is a table or an entity that contains a compound primary key. The reason it's a compound primary key is that it has two parts. It has two attributes comprising that primary key: appointment date and dog ID. Okay. Now, maybe it sounds like a bit artificial, this example, but I hope that you see why it makes sense to have a compound key. You see, you cannot just use appointment date, because on one appointment date, you can have multiple dogs, right? You cannot just use dog ID to capture information about hikes, because one dog, let's say with ID 101, can be walked on several dates. That's why to uniquely identify each dog hike, you need to have a compound key that consists of dog ID and appointment date. In that case, the hike information, the hike records will not be duplicated, in the sense that you will be able to uniquely identify each hike record in your database, okay? So once again, those are the essential elements of a good database model. Those essential elements are entities, relationships, primary keys, foreign keys, right? So this is the essence of creating a good, those are the most fundamental concepts for creating a good database model. Hopefully you're able to kind of attach visualizations to each of those concepts, right? When I say an entity, you think about a table storing information about customers. When I say relationship between two tables, you're thinking, okay, this relationship is implemented by inserting a primary key from one entity into another, okay? So that's the essence. This is the essence of creating a good data model. For the next couple of lectures, we'll zoom in on data modeling. We'll talk about ERD modeling, entity relationship diagramming method, okay? We'll talk about some nuances that will help you to create a simple, non-redundant, and scalable database that is normalized, okay? But for now, we just had an introduction where we just gave examples of those concepts for the purpose of you being able to visualize what those concepts mean at the database level. So that's it. That's it for today's lesson. Do you have any questions or comments? Is there anything that I forgot to address? Is there anything that still seems to be confusing? Go ahead. We still have a couple of minutes to discuss it. So everything seems to be clear. All those ideas seem to be clear for now.
Yes, sir.
Okay, well, that's good. I mean, we're going to be repetitive in the sense that we're going to talk about those ideas again when we talk about nuances of ERD modeling. So that will be your chance to voice some concerns if something seems to be unclear. Okay, friends, so I'm done with this lesson. So I'll go ahead and I'll stop recording.